Hello and welcome to Algebraic Expressions chapter, where today we're going to look at negative and fractional indices. So we can use the laws of indices with any rational power, where the rational numbers are the numbers that can be written as a over b. So the rational numbers can be expressed as a over b, where a and b are integers, and irrational numbers cannot be represented as a over b. You might get a question where you have rational numbers and irrational numbers to prove something, and that is really useful to know what rational number is. Also, we have a recap from 1.1 index laws, where we looked in the first chapter, in the first topic of the chapter, on those rules. So if you don't know them, you might want to come back to the video and learn them. But now we have more rules, and this is a to the power of m over n, a to the power of minus m, and a to the power of 0. Now, the easiest rule is that anything to the power of 0 is 1. So this one here is saying that anything, even 9999 to the power of 0 is 1. So anything to the power of 0 is 1. 0 power 0, also 1. The second rule is saying that if we got a minus m, then it is 1 over a power m. So let's say we had a 7 minus 2, that will be 1 over 7 squared. So it inverts it. So what happens with that minus, it disappears and the whole fraction gets inverted from 7 minus 2 over 1 to 1 over 7 squared. And the last rule, which is over here, so we covered this rule first, this rule second. Now you're going to cover this rule, which is the third new rule. And what happens here is that if you have a to the power m over n, then this, the top one, represents the power, and the bottom part represents the root. So it's easy to remember because the m has the power over the root. The root, you can think of this as a ground, and the three roots are under the ground. So this is a root, square root, and the power is on the top because it is more powerful. That's how I remember the way to remember which one is which. But now we can power it and square root it, n root it, whatever the n is, or we could square root it first or n root it first and then power it to the n. So it doesn't matter which order you do it in, you power by m and you square root by n. So for example, if we got 7, or let's just do a better number like 4, 3 over 2, then we can do like this is the power, this is the root. So we can power it first by 3, or we can root it by 2 first. Square rooting by 2 would be the easier part, and this would be 2, and now we power it, so that is 8. So 4 to the power of 3 over 2 is 8. Now we're going to see some examples for normal indices that we used in the first topic. So what we do here, where x to the power of 3 over x power minus 3, this is the same as saying x power 3 divided by x power minus 3. which is the same as saying x to the power of 3 minus minus 3, which is plus, so it's x to the power of 6. Now we got another one where we got the multiplication rule, and what we do here is if they have the same bases, we're going to add the powers together. So adding them together gives us 4 over 2, which is 2. So that means that this is x squared. Now in here we use the rule that is here, and we multiply 3 by 2/3, and that will be x squared, because 3's cancel and we're left with a 2. Now we got the following question. We turn those ones into powers like so. So we turn them into fractions from decimals. So here is 3 over 2 and here is minus 1 over 4. And then we can use the division rule of laws of indices for the powers, because we got bases the same, which are x and x. So 2 divided by 4 is 2 over 4, which is 1 over 2. And then if we do 3 over 2 minus minus 1 over 4, then we add them because it's double negation, and 6 over 4 plus 1 over 4 is 7 over 4. And that is x to the power of 7 over 4, which in decimal terms is going to be 1 3/4, so that is going to be 1/75. Now we deal with 125x to the power of 6 cubed. So what happens here is that we can change that square root, cube root, into a fraction, and we can do that using this rule over here, because we know that the n, which is at the bottom, is our root, so that will be the cube root, and that's why we put 1 over 3. So this here is the same as saying this to the power of 1 over 3. And now we just use this rule over here. The power is multiplied by each term, and therefore 125 to the power of 1 over 3, and x to the 6 multiplied by 1 over 3. So here we got cube root of 125, and here we got x to the power of 2. So cube root 125 is 5, and then we have x squared, so the final answer is 5x squared. Now this question is very similar to the exercises in the 1.1 section. So what happens here is we divide the top all by the bottom, so this is divided by this, and this is divided by this. So 2x squared over x to the power of 5 is going to be 2x power minus 3. And here minus x over x to the power of 5 is minus x to the power of minus 4. And we can leave it as that. However, this doesn't look really nice, and what we can do is, because we know this rule over here, a to the power of minus m is 1 over am, so what happens here is that 2 is left on top, and x cubed is inverted to the bottom, like so. And this is the final answer, because what's happening here is that 2 multiplied by x minus 3, using the following rule here, we see that this is 2 times 1 over x cubed, and this is 2 over x cubed. But for the second one, we got negative 1 times x minus 4, which is the same as saying minus 1 times 1 over x power 4, using the rule highlighted over here. Now, evaluating normal numbers, we can solve the following questions. So 9 to the power of a half, we'll be looking at this rule over here, which says that the top is a power and the bottom is a root. So what happens here is that we square root it because there's a 2, and we power 1, and that is 3 power 1, which is 3. So 9 to the power of a half is the same as square root of 9. Now we have 64 to the power of 1 over 3. This is the same as saying cube root of 64, which is 4. Because the bottom means root and the top means power, but anything to the power of 1 is just the same thing, so it's 4. Now we got 49 to the power of 3 over 2. What happens here is that 49 can get square rooted first, or it can be to the power of 3 first. Well, 49 to the power of 3 would be really difficult to calculate, so we're dealing with the square root first, and then the power, and that would be 7 to the power of 3, which is 343. Now we got 25 to the power of minus 3 over 2. Now whenever we got negative in a power, we know by this rule here that we go into invert the fraction. So this becomes 1 over 25 power 3 over 2. And now we apply the following to the denominator. So we go into square root the 25, power it by 3, because this one is power and this one is square root. And we square it by 2 because the denominator is 2 and the numerator is 3, so we go into power 3. And this means that this is 1 over 3, and this means that it's 1 over 5 to the power 3, which is 1 over 125. Now we're doing this question where it says, given that y is the following, express each of the following in the form kx to the power of n, where k and n are constants and a is y to the power of a half. So we have y to the power of a half, and we know that y is 1 over 16 x squared. So we plug in this value of y into this value of y. So this means that 1 over 16 x squared is to the power of a half. Now we can use our index laws from chapter 1.1 to solve this using this one here. So we're going to multiply by the power. That is going to be 1 over 16 to the power of a half, and x to the power of 2 times a half, which is the same as 1 to the power of a half, 16 to the power of a half, and x to the power of 1, which is just x. Now we're dealing with 16 to the power of a half at the bottom and 1 to the power of a half on the top. And square root of 1 is just 1, and square root of 16 is 4. So the following answer is 1 over 4. I forgot about the x as well, so x will be here, and it will be x over 4. Now for the part B of the question, we have 4y inversed. So does that mean we plug in the value of y to be 1 over 16x squared, and we do power minus 1. What we do here is first we focus on the brackets and the powers, because if we look at BODMAS, the multiplication is here, the brackets are here, and the powers are here. So we do the brackets and the powers first, and the multiplication is last. So here we're going to apply the -1 power onto each of those. So that will be 1 over 16 all to the power of -1, and x to the power of 2 times -1. So that will be the following. And now we have 4 bracket 1 over 16 inverted, so that is 16, and we have x to the power of -2. Now I use the square brackets to let you see what's happening. So this is inside here, and this is inside here after the power. So that's what's happening. And now what we can do is to put 16 over x squared, because 16x to the power of -2 is the same as 16 times x minus 2, and you can use the following rule here to invert it and put it at the bottom, which is 16 times 1 over x to the power of 2, which is 16 over x squared. And that's how I went from here to here. Now we just multiply by 4, so 16 times 4 is 40 plus 24, which is 64, and then we over x squared. Now we're going to do some exercise questions so that you can do the whole exercise yourself. So if we look at the first question of H, so now we go to exercise questions. So what happens here is that we use division rule, because we got bases that are the same, so we can do 5 x and 7 over 5 minus 2 over 5, which equals to 5x 5 over 5, which equals to 5x power 1, which is 5x. And we did this by using the division rule from the first topic. Now we got 343 over 512 to be to the power of minus 2 over 3. First we're going to flip the fraction, because we got an inverse here, and what we do with inverses, we just change up the fraction. So what happens here is that 512 is now at the top and 343 is at the bottom, and that is to the power of 2 over 3. Now what happens here is that we cube root the 512 and cube root the 343 and power them by 2, because this is the power and this is the root, and it applies to both the bottom and the top. Now what happens here is that we're going to cube root the 512, which is 8, and cube root the 343, I believe it's 7, yes it is 7, and then we just do the rest like this. Now we got the following expression where 4/9x to the power 4 is in brackets and it's powered to 3/2. So the same, we apply the power to each term of the bracket by using the following rules, and that is 4/9 all to the power of 3/2 times x to the power 4 times 3/2, and that is going to be, well, we're dealing with this first. So what happens is this is the root, this is the power. So first of all, we're gonna square root it first. So square root of 4 and square root of 9, and we're going to power it by 3. And now this is going to be times x, 12/2, which is 6, and we're dealing with this here. This is 2 cubed, which is 8, and 3 cubed, which is 27, and this is the following answer. Now in this question over here, we got this whole fraction here, and the numerator gets divided by the denominator. So this part is divided by this part, and this part divided by this part. So that means that 5x is divided by 15x cubed, and also 3x squared is divided by 15x cubed. So what happens here is we can treat them as separate fractions and then connect them together. So 5x over 15x cubed, so 5/15 is 1/3, and x to the power of 1 minus 3 is going to be minus 2, so x minus 2. Now we add 3/15, so that's 1/5, and 2 minus 3 is minus 1. Now what we can do is we can invert those to give us 1/x squared, and this one to give us 1/x. Using the following rule over here. So what happens is we have 1/3x squared. Let's get rid of this. And also we have plus 1/5x. Now the last question, which is 4a, we have to find 1/4 power of 81. So again, this is power, this is square root. So what happens is that 4th root of 81 is going to be 3, because 3 times 3 times 3 times 3 is 81. And now simplifying x, and in brackets 2x to the power of minus 1/3 to the power of 4. First we're going to use this rules over here, So it's going to be 2 to the power 4 and x to the power of minus 1 over 3 times 4. And now x outside still, and 2 to the power 4 is 16, and x to the power of minus a third times 4 is minus 4 over 3. And now we just multiply this by x, so we're going to add this to 16x minus 4 over 3, and we just do this by adding the powers together, so plus 1 over 3 here, where this will be 16x to the power of minus 1 over 3, and then we can put this by using this rule. We can have x minus 1 over 3 the same as 1 over x to the power of 1 over 3. So that is 16 over x to the power of 1 over 3. So now you should be able to do the negative and fractional indices on 1D. I hope this video helped you. See you in the next topic.